Far beyond Neptune, in the silent outer reaches of our solar system where sunlight grows faint and temperatures plummet toward absolute zero, a remarkable event has been recorded. The James Webb Space Telescope, humanity's most sophisticated eye in the cosmos, has captured something truly unprecedented, an event that challenges our understanding of the objects that drift between the stars. 3I, Atlas, the third interstellar visitor ever confirmed to enter our solar system, has collided with a massive object in space. Unlike minor anomalies or subtle signals, this was a dramatic, high-energy encounter, releasing debris and light on a scale rarely witnessed. Webb's infrared instruments were perfectly positioned to detect the moment of impact, as a large body, possibly a rogue planetesimal, a massive cometary fragment, or a wandering chunk of interstellar debris, intersected the path of this enigmatic traveler from another solar system. The collision produced a brilliant, expanding cloud of debris, composed of ices, silicates, dust, and possibly metallic fragments. For a fleeting moment, 3I, Atlas transformed from a dark, silent wanderer into a glowing beacon against the black void of interstellar space. For scientists, this represents a once-in-a-lifetime opportunity, a glimpse into the interior of a fragment of another star system. Normally, only the outer surfaces of such objects can be observed. But the violent forces of this impact exposed the hidden core, revealing molecules, minerals, and compounds that have never before been studied directly. These interstellar visitors are far more than cosmic curiosities. They are time capsules, carrying the chemistry, history, and dynamics of alien worlds. Each carries traces of the processes that formed planets, moons, and possibly the precursors of life in a distant star system. Observing a collision like this allows researchers to study these materials in a natural laboratory that no Earth-bound experiment could ever replicate. Webb's powerful spectroscopic instruments can detect the fingerprints of exotic carbon chains, frozen volatiles, silicates, and metals, providing a chemical map of a solar system far beyond our own. The implications extend far beyond the object itself. For one, this collision suggests that interstellar space is not the empty void we often imagine. Instead, it may be populated with streams of debris, fragments of shattered worlds, and wandering comets, drifting between stars for millions of years. Events like this provide insight into the chaotic and dynamic environment between star systems, revealing interactions that shape the distribution of matter across the galaxy. 3I, Atlas itself is an extraordinary object. Unlike its predecessors, Oumuamua, with its elongated, cigar-like shape, and Borisov, which resembled a more typical comet, 3I, Atlas displays a hybrid character. Its reflective icy surfaces indicate frozen volatiles, while its dynamic behavior hints at rocky or metallic content. The collision has now peeled back its outer layers, allowing Webb to capture data on its internal composition, an unprecedented glimpse at the building blocks of an entirely different planetary system. This event also sheds light on interstellar dynamics and the abundance of rogue objects. The debris produced may travel for millions of years, drifting into other star systems and potentially contributing raw materials for planet formation, or even seeding the chemical foundations of life. Studying the debris cloud, its expansion, and composition can help scientists refine models of high-velocity impacts, material dispersal, and the movement of matter across galactic scales. The collision further highlights the importance of constantly monitoring the skies. Discoveries of this magnitude often occur by chance, a testament to the alignment of timing, technology, and cosmic happenstance. How many other dramatic events occur unseen, hidden in wavelengths beyond our instruments or at distances beyond our reach? Webb's observation underscores the value of vigilance, preparation, and the deployment of increasingly sensitive instruments. Beyond the immediate scientific impact, the collision invites reflection on the universe as a dynamic, interconnected system. It reminds us that space is alive with motion, energy, and chance encounters. Collisions between interstellar objects, while rare on human timescales, are natural and recurring phenomena in the galaxy. They redistribute material, expose hidden structures, and ultimately shape the evolution of planetary systems. Moreover, this extraordinary event carries profound philosophical, cultural, and even existential significance. For millennia, humans have turned their gaze skyward, trying to decipher the mysteries of the heavens. From the earliest astronomers who charted the movements of planets with nothing more than the naked eye, to the architects of ancient observatories like Stonehenge or the Mayan pyramids, the cosmos has always inspired curiosity, awe, and wonder. Each era of discovery, Copernicus challenging the geocentric model, Galileo peering through his first telescope, Newton unraveling the laws of motion, has shifted our understanding of our place in the universe. With the Hubble Space Telescope, humanity glimpsed the deep cosmos, witnessing galaxies billions of light-years away. Now, the James Webb Space Telescope allows us to observe not just the distant past, but also sudden, fleeting events in real time. The collision of 3I, Atlas is a rare, dynamic spectacle, unlike the serene orbits and predictable motions we usually study. For a brief moment, two objects from beyond our solar system, strangers in the vast expanse of interstellar space, met in a violent but revealing encounter. It is both alien and eerily familiar, destruction and creation intertwined, governed by the same physical laws that shape the Earth and our solar system. In this way, the event becomes a metaphor for the universe itself, simultaneously chaotic and orderly, unpredictable yet comprehensible. For the scientific community, the aftermath of this collision will be studied for years, perhaps decades. Every particle in the debris cloud tells a story. Dust grains carry evidence of the conditions under which they formed. Spectral lines reveal the presence of water, carbon compounds, silicates, metals, and organic molecules. By analyzing these signatures, scientists can reconstruct the history and composition of a fragment of another solar system, essentially holding a piece of an alien world in human knowledge. These insights may guide interstellar navigation for future spacecraft, improve planetary defense strategies by understanding high-speed collisions, and inform our search for habitable worlds far beyond the Sun. In a sense, 3I, Atlas has provided humanity with its first real encounter with the hazards and dynamics of interstellar space. But the significance extends beyond science. This event connects us to the grand story of matter, life, and cosmic evolution. Every element heavier than hydrogen, oxygen, carbon, nitrogen, iron, was forged in the hearts of stars and scattered across the galaxy through supernovae and stellar winds. Interstellar travelers like 3I, Atlas are not just inert rocks. They are carriers of this ancient material, a tangible link to the broader cycles of cosmic creation. By studying their composition, we learn not only about the universality of planetary formation but also about the potential prevalence of life-essential molecules across the galaxy. The collision reminds us that the building blocks of life are not unique to Earth. They are the inheritance of the universe itself. The implications ripple even further. As debris disperses through the solar system, some fragments may eventually integrate into new planetary systems, perhaps contributing to the raw ingredients for future worlds, or even life, somewhere else. In this way, an event so distant and brief can have consequences spanning millions of years and light years, emphasizing the interconnectedness of the cosmos. Ultimately, the collision of 3I, Atlas is far more than an isolated astronomical incident. It is a living demonstration of the ongoing motion, interaction, and transformation that define the galaxy. The universe is not static. It is a vast, dynamic stage, where matter continually moves, collides, and reshapes itself. Through Webb's lens, humanity witnesses these interstellar dramas unfold in real time, gaining not just knowledge, but perspective, reminders that our solar system, while vast by human standards, is a tiny speck within a universe of unimaginable scale and complexity. In this single, fleeting event, science, philosophy, and wonder converge. It tells a story of curiosity meeting chance, of technology meeting opportunity, and of humanity glimpsing the raw, unfiltered processes of cosmic evolution. 3I, Atlas's collision does more than expand our understanding of space. It offers a connection, a profound reminder that exploring the universe is as much about discovering ourselves and our place within it as it is about uncovering distant stars and planets. In watching these interstellar travelers collide, we see the universe as it truly is: alive, dynamic, and endlessly fascinating. The event inspires not only scientists, but dreamers, philosophers, and anyone who has ever looked up at the night sky and wondered what lies beyond. It reminds us that knowledge, discovery, and wonder are inseparable, and that each breakthrough, no matter how technical, carries a human story of curiosity, perseverance, and the eternal desire to understand the cosmos. Through the collision of 3I, Atlas, humanity has glimpsed both the fragility and the grandeur of our universe, witnessing firsthand the forces that shape worlds, stars, and galaxies alike.